Alright, so we have a system of 3 equations with 3 unknowns, x, y, and z, and we're going to use matrices and row operations to solve for x, y, and z. So first thing, to put it in my augmented matrix, so just using the coefficients and my answers. Alright, so the very first thing that I want in row 1, column 1, I need a 1. Ideally, one of the other values in this first column would be a 1, and I could just switch it and problem solved. But that's not the case here. So in order to make this, force this to be a 1, it's a 2, so I'm going to divide row 1 by 2, or multiply by a half. So I'll end up with 1. We can do fractions or decimals. 3 divided by 2 is 1.5. 1 divided by 2 is 0.5. And 9 divided by 2 is 4.5. All of the rows stay the same. And so now we'll use, we have row 1, column 1 as a positive 1. And so everything below it we need to force to be 0. So we'll use the 1 to our advantage. If I multiply 1 by -4 and add it to 4, I'll get 0. So in order to force this to be 0, I'm going to do -4 row 1 plus row 2. And then likewise to row 3, if I multiply row 1 by -6 and add it to row 3, it'll force that last row to be 0 as well. So let's come out here. Just to keep everything in line, if I multiply this top row by -4, I'm going to get -4. What is 3/2 times -4? -6, -2, and -18 when I multiply by -4. And if I multiply by -6, I'm going to get -6, -9, -3, and -27. That's what I'll get in row 1 when I multiply. So I'm adding these values to row 2, and I'm adding these values to row 3. You can't see that. There we go. And so row 1 is going to stay the same. I'll have 1, 1.5, 0.5, and 4.5. And now to row 2, I'm adding these values. So -4 plus 4 gives me 0. -6 plus 1 gives me -5. -2 plus -3 gives me -5. And -18 plus -7 gives me -25. In the last row, adding these values, I know that kind of looks confusing, but adding these values, 6 plus -6 gives me 0. 2 plus -9 gives me -7. -4 plus -3 gives me -7. And -8 plus -27 gives me -35. Alright, so column 1 is done, so I'll move to column 2. I need, remember on this diagonal, I need 1s, and everything else below it to be 0. So this row 2, column 2, I need this to be a 1. None of my other, the equation below it, the line below it, is not a 1, so I can't switch it. So to make this entry right here 1, I can simply multiply by -1/5. So I'm going to do -1/5, row 2. Everything else will stay the same. So I'll have 1, 1.5, 0.5, and 4.5. And then multiplying row 2 by -1/5, I get 0, 1, 1, 5. And row 3 stays the same. Now again, we're wanting this last entry to be 0 as well. So what could I do to force that to be 0? So using row 2, column 2, using that 1 that we've created. If I multiply that by 7 and add it to my last row, so 7 times row 2 plus row 3. Again, the first row will stay the same, 1, 1.5, 0.5, 4.5. Second row stays the same, 0, 1, 1, 5. And my third row, multiplying the middle row by 7, I'll get 0, 0, 0, and 0. Oh. Lo siento mucho. Alright. Right. We like it to be outside the row that we're actually changing, so my apologies. Alright, so I ended up with a row of zeros. So what this tells me is I don't have a unique solution. Right? If I look here, I know that y plus z gives me 5, but I don't know what y is and I don't know what z is. So I actually have no unique solution. There's many solutions. We're not going to worry about that right now, though. I don't have a unique solution. Right, so you think about, so this gave me zeros. So if you think about what this middle row tells me, x plus y equals 5. So what are some combinations for x and y that would give me 5? 3 and 2, 1 and 4, 7 and negative 2, 6 and negative 1, 5 and 0, right? There's an infinite number of possibilities. So I got lots of solutions, so no unique solution. We're not going to go through trying to find any of them. So no unique solution.